Hey there! We're all used to hearing about averages, right? They're everywhere. But what if I told you that relying on the average is like trying to understand a movie by only looking at a single frame? Today, we're going to dig into the tools that show you the rest of the film, giving you a way richer understanding of pretty much any data you come across.
Okay, so let's jump right in by talking about something we all think we know like the back of our hand, the average. But as you're about to find out, putting all your trust in the average can be, well, seriously misleading.
So let's really think about this for a second. When you see an average number, say the average salary for a job, or the average temperature in a city, are you actually getting the full picture? Is that single number really telling you everything you need to know?
To see what I mean, just look at these two sets of numbers. Dataset A is super consistent, right? All tens. Dataset B, on the other hand, is all over the map. Now, here's the kicker. Both of these datasets have the exact same average, an average of 10. Now, even though their center point is identical, would you say they're telling the same story? No way.
And that right there is the whole point. The average tells us about the center of the data, but it tells us absolutely nothing about the spread. It's like a GPS pin showing you the center of a city, but it doesn't tell you if all the houses are packed tightly together or if they're spread out for miles in every direction. That spread, that's the missing piece of the puzzle.
So if the average isn't enough, what is? How do we actually go about measuring this spread thing? Well, lucky for us, statisticians have developed a whole set of tools designed to do exactly that. These tools are called measures of dispersion, which is really just a fancy way of saying they measure how spread out or dispersed your data is. They answer a really simple but important question. On the whole, how far are the individual data points from the center?
So today, we're going to stock our data analysis toolkit with 4 of the most important measures. We're going to start with the simplest one and work our way up to the real powerhouses of statistics.
All right, first up, the easiest one to get your head around, the range. It's incredibly simple, but, and this is a big but, its simplicity comes with a major weakness.
The range is pretty much what it sounds like. You just find the highest value in your data, find the lowest value, and subtract one from the other. That's it. It gives you a super quick bird's-eye view of the total spread from one end to the other. For example, let's say we have this really simple data set here. The numbers 1, 2, 3, and 4. The minimum is obviously 1, and the maximum is 4.
So the math is about as easy as it gets. 4 minus 1 gives us a range of 3. Simple, right? But this is where we have to be really careful.
See, the range has a fatal flaw. It is a complete sucker for outliers, those one-off extreme values that don't really fit with the rest of the group. So what happens when we throw one of those into the mix?
Okay, let's take our nice clean data from before, but now we're going to add a single massive outlier, the number 50. Our minimum is still 1, but our maximum just took a huge leap.
And just look what that does to our measure of spread. The new range is 50 minus 1, which is 49. It jumped from 3 all the way to 49 because of one single number. Suddenly, this measurement is telling a totally different and frankly misleading story about our data.
And that really gets to the heart of it. Because the range only cares about the 2 most extreme points, a single wild number can throw the whole thing off and give you a completely warped view of what's actually going on.
So, what's the fix? How do we get around this outlier problem? Well, we use a smarter, more robust tool, the interquartile range, or IQR for short. The idea is brilliant. Imagine you line up all your data from smallest to largest. The IQR basically says, hey, let's just chop off the lowest 25% and the highest 25% and ignore them. It then measures the range of what's left, the middle 50% of your data.
And that's the beauty of it. By zeroing in on that middle chunk, it completely ignores the extreme outliers way out on the ends. This gives you a much more stable and realistic idea of the data's typical spread.
Okay, so the IQR is awesome for ignoring outliers. But sometimes you actually want a measure that takes every single data point into account. And for that, we need to bring out the big guns, variance and its much more famous cousin, standard deviation. These are, without a doubt, the most important measures of spread in all of statistics.
Now, variance sounds kind of scary, but the idea is actually pretty clever. For every single data point, it measures its distance from the average. Then, to make all those distances positive, it squares them. Finally, it just takes the average of all those squared distances. What you end up with is a single number that represents the overall spread of your entire data set.
But there's a weird little catch.
because we squared all the differences, our final answer is in squared units. So if your data was in dollars, the variance would be in dollars squared. What in the world is a dollar squared? It's not exactly intuitive, is it?
And this is where standard deviation comes in to save the day. It does one beautifully simple thing. It takes the square root of the variance. By taking the square root, we undo that squaring we did earlier, and poof, we're back to our original units. So now we have a number we can actually understand, an intuitive measure of the typical or standard distance of any data point from the average.
So let's bring it all home. We started this journey realizing that just looking at the average is like watching a movie with the sound off. You're missing a huge part of the story. But now, we have the tools we need to turn the volume up and get the full picture.
Here it is, your new two-step framework for analyzing pretty much any data you ever come across. Step 1. Find the center. Use the mean or the median, but don't stop there. Step 2. Always measure the spread. Use the IQR or, more commonly, the standard deviation. You do those two things together and you're not just looking at a single frame anymore, you're telling the full story.
So I want to leave you with this question to chew on. Think about all the averages you see thrown around every single day. In news reports, in financial data, in sports. Now that you know to ask, okay, but what's the spread? Where is that simple question going to totally change your perspective? Where is it going to reveal a hidden story that was there all along, just waiting for you to look a little deeper?